is just about note taking, and it's theoretical. There is no analysis, there's no calculation here whatsoever. So let's start with oxygen today. I'm trying to look for my pen. So sorry, I want to set up my. So oxygen is actually, let's start with the properties. You can write as I set up my pen. So oxygen is a colorless so we check nitrogen the last time, right? So today we are going to oxygen. Awesome. So let's check the properties first. Guys, please give me 1 minute. I want to attend things. I have a visitor, please, just a few seconds. So properties. So one of the first properties. Properties. We have the colorless and it's an odorless gas. So today, please, you bear with me because you'll be writing notes a lot today. Like I said, it's highly theoretical. Supports combustion. This aspect is just about note taking, and you have to read it. It reacts readily with many substances. It reacts readily with many substances. Here are the major properties. It can combine with metals to form oxide and ore. Let's check the uses. They are used the major source of respiration. Major source of respiration for welding and cutting. Let me repeat it. For welding and metal cutting. Welding and metal cutting for steel manufacture. For steel manufacture. For medical oxygen. For medical oxygen. Let me come again. The use of oxygen includes respiration for welding and metal cutting, for steel manufacture, for medical oxygen, for medical oxygen. Let's go to CO2. But let me see if I can copy this thing to you. The carbon dioxide, which is CO2. They are also colorless and odorless gas. They also support combustion. No? They do not support combustion. They don't lime water making. They don't lime water making. Some of the uses include they are used as fire extinguishers. They are also used as carbonated drinks. They are used in carbonated drinks. Photosynthesis will breathe out CO2 so that the plant can make use of it for refrigeration. I hope that is taken. Let's quickly check noble gases. They are chemically inactive, that they are unreactive gases. They don't have any charge. And also, they have complete outer electron shells. Some of the uses include it helps in filling electrical bulbs. That's argon, actually. Argon helps in filling electrical bulbs. Neon or advertising. They can ask for individual uses of noble gases. They can say the uses, or they can say one of the uses of neon is dash for advertising signs. Yes, signboards. Helium, balloons, and airships. I hope that is taken. Can I move to the next slide, please? So let's check another subtopic. They can ask question on air being a mixture. Like I said, air is a mixture because of this, except dash. Can I move on? Can I proceed? Okay. Yeah, it's a mixture. Yeah, a mixture because of the following properties. Following reasons. Number one, there are gases. The gases in the air are physically mixed. The composition is not fixed. The gases can be separated. No energy changes. No energy change occurs during mixing. So the gases of yes, they are physically mixed. So since they are physically mixed, they can be separated. And the composition is not fixed. That's why I said about the percentage of each gas is there. It can vary a little bit, just a slight changes, and no energy change occurs during mixture. Can somebody remind us how we can separate air? We did it under separation techniques. What is the method we use in separating air?
Fractional distillation.
Very good. So air is separated by fractional distillation. And do you still remember how fractional distillation works? In fractional distillation,
Different boiling point.
exactly, different boiling points. So before you can ask a question on this, the steps involved in separation of air. The first thing you do is you remove impurities. Removal of impurities. There are some impurities that can be present in air. For example, dust, water vapor and all. The second thing you do is you compress the air. Compression of air. That is, you will compress the air. And after compressing the air, there's something called liquefaction. We convert air to liquid at a very low temperature so that we can heat it. And if we heat it, we can separate the mixture there based on their difference in boiling point. So that's how we do liquefaction. So in case they ask you, liquefaction is conversion of air to liquid. At very low temperature. And the reason why we use a very low temperature is that by the time we are converting it, so that other uh, mixture that are there, other gases that are there that has low temperature or that has high temperature will not be lost during liquefaction. So that's why we convert air into liquid with a low temperature at a very low temperature. The fourth one is then we use fractional distillation. The components are separated based on boiling point, as we've said. So from removal of impurity to compression of the air to liquefaction, then to the first final one where we eat it. After eating it, the components will be separated based on their boiling point. So the one that has the lowest boiling point will first leave, and there's a channel like a column that we can use to trap it. After that, the next one. So and after that, the next one that has a relative closer boiling point will leave. Follow by till everything is complete. So they'll be leaving one by one. So let me quickly tell you the boiling point of individual. So the boiling points of air component. Nitrogen has a boiling point of about negative 196 degrees. Argon has a boiling point of about negative 186 degrees. Oxygen has about 183 degrees. So it simply means that the order of collection of this air, if you want to collect it in the fractional column, that means we'll be in first because it has a negative 160 degrees C. Then to argon, then to oxygen. Is that it? Uh, can just start that. I don't jot in it. Confidence, I don't jot in it. So this aspect, let me just give you. They don't have question here. Variation in composition of air. They cannot. But let me guess. Uh, variation in composition of air. So what this aspect talks about is the composition of air changes. You know, we said we have relative change in the composition of air. So there are some little factors, or say, let me say, common factors that contribute to the variation in the composition of air. For example, industrial activities, they can actually affect the composition of air. If you are in an environment where there are high industrial activities and there is release of some compounds into the air, there's a way it can create or deplete the ozone layer and create a variance in the composition of the air. Respiration also can cause it. Photosynthesis can cause it. And burning of fossil fuels. So these are the things that can cause the variations in the composition of air. So the first one is industrial activities. The other one is respiration. Burning of fossil fuels. Photosynthesis. Altitude, humidity, and the last. And the light. And they can ask you, the urban here and the rural here. You know, urban here, there are many industries there. So it simply means urban here will contain more pollutants more CO2 than the lower air. Here's the heart portion like that. Let's quickly move to uses of air. You know all these ones. They enables combustions, like oxygen, for example. They support life. They are sources of industrial gases. Wind energy, kind of materials, and other fuels. So this is the end of the hair. The few things you need to pay attention to when you are studying again is that you should not mix the boiling point of the component of the hair together. Do not mix up the boiling point. Understand the approximated value for the boiling point of oxygen, the approximated value for the boiling point of nitrogen, and how. I think, and you should pay attention to the individual properties of the various gases that are present in the hair. So I think that's all about that. So let's move to another topic. So are you done writing this? Let's move to water. Let's move to water. So the first thing we should check hard water and soft water. Let me just use a tabular form. I think tabular form would be better. The difference between hard water and salt water. In terms of mineral deposits, So hard waters, they contain mineral ions. They contain mineral ions. They contain mineral ions, which include calcium, copper, magnesium, which can help to coat hair strands. Just write they contain mineral ions. That's why I'm abbreviate it. Contain they contain mineral ions. These ones, they have no or little mineral deposits. In terms of ladder, the hard waters, they have hard ladder. They are hard to ladder. So hard to ladder simply means when they are mixed with soap, they doesn't form ladder easily. And if you want to make it ladder, you have to use more, like more soap. You have to increase the number of the soap products that you are using. So when mixed with soap, it doesn't lather easily. Doesn't lather easily. So to this other guy here, I wish I can be dictating for you. It is easy to lather. It is salt water. So that's just the another difference between hard water and salt water. Another one is that this one reduce moisture absorption. This one increase hydration. That's another major difference there. What else can we get? And also, water is a compound, not a mixture, like the hair. Please don't mix the two together. Water is a compound. And can somebody tell us different reasons why water is a compound? Well, give me one reason why water is a compound. Do you remember the reason I gave to you why air is not a compound? and why here is a mixture. Now check it with that. Can you tell me the reason why water is a compound?
Water cannot be separated by normal physical means.
Very good. They can only be separated by chemical means. So you can write it down. You can write that down. So water is a compound because of these reasons. Because, so Paul said, they can only be separated. He said they can't be separated by physical means. This means they can only be separated.
I don't know.
Who's talking there?
Okay, Justice.
Okay, Justice, how are you now?
I'm fine.
What else in your chemistry?
16.
Sister, that's. So what other reasons is why water a compound?
It has hydrogen.
That's hydrogen. So any element, anything that has hydrogen is a compound.
There are two now. It contains oxygen and hydrogen, making it.
Yeah, because there are two. Because there are two. Okay, do you know air contains nitrogen? Air contains CO2. Air contains noble gases, argon, neon, krypton. Does that make air a compound?
It makes it a compound because both of them are not it has hydrogen and oxygen, and it is not the same as water, I think. So, and they combine chemically.
Very good. The elements oxygen and hydrogen combine chemically. That's what I'm expecting. Because they contain oxygen and hydrogen does not really mean they are a compound. Because the element they combine chemically. Let's write that down. The element hydrogen, oxygen, they combine chemically. And that is why when you check the properties of water, it is extremely different from the properties of hydrogen. It's different from the properties of oxygen. But when we check the properties of air, it is takes down to the properties of the individual element because they did not combine chemically. So the properties of oxygen of water differs from hydrogen and oxygen. Do we get it? So that is another reason why it is a compound. So the element hydrogen, oxygen, we said they combine chemically. Please, what happened? Sorry.
I have a question from the boiling point of those elements that makes up air.
Okay.
So you said they were negative. We don't know that part. Negative 196. And now my question is, what if you want to convert it to Kelvin, or what if the options are in Kelvin? How will you now know which one is the correct one?
We had the sensitivity to minus 185. It will become positive. But nitrogen will still have the lowest boiling point. Now let's do the mathematics. What is 273 minus 195.8? Or let me say, what is the temperature, the boiling point I give you? I give 186, I mean.
Yes.
It's actually 185.8, but it's approximately 186. So minus 186. So my calculator said 77. It simply means the boiling point of nitrogen in Kelvin is 77 Kelvin.
Okay.
Right?
Okay.
Now, argon is 186,
Mm-hmm.
So what is 273 minus 186? That should be 67.
87.
87, sorry, 87. Now, between 77 and 87, which one has lower boiling point? Is it not 77?
Yes.
And that is why nitrogen will leave the column before argon. So we collect nitrogen first, then we collect argon, then we collect oxygen, then we collect CO2. In fact, many times CO2 they sublime. By sublimation, we can use fractional addition plus sublimation to collect CO2. You know, they form all these what's it called? All these creamy gelatinous they sublime. So they get it now. They have negative value, and that is why they can ask this question, because and that's why I give you that order of collection of the hairs. Is nitrogen first too? You know, some people be looking at the temperature. Okay, nitrogen has the highest temperature. That's a temperature of 195 or 186 degrees. And people are forgetting the negative. I know. Nitrogen has the smallest boiling point. And if you remember in fractional distillation, the smallest boiling point will leave the column first before the one that has the higher boiling point. Remember when we want to separate ethanol, water, and all these guys in crude oil. Now we said, I think ethanol has about 78 degrees C, something like that, and water has about 100 degrees C. So ethanol will leave before water. So the one with, when you are eating something, the boiling point of the smallest one will be the first one to boil, right? So by the time ethanol starts boiling, it will start leaving and it will be trapped at the column and to be converted back to liquid. Same also the water. Water will boil at 100 degrees C. So once it reaches 100 degrees C, water will start to boil also and to be trapped. Hope that is taken.
Yes, thank you.
Yeah. So another reason why water is a compound, Paul said they can only be separated by chemical mix. Justice said the elements there they combine chemically. Another reason is that they have fixed composition. Anything that is a compound always have fixed composition. They have a fixed composition. Can somebody tell us the composition of water by volume? It's not 2:1. Hydrogen to oxygen is 2:1 by volume. That's hydrogen to oxygen. And that's how we call it H2O. In case they ask. And in case they ask you about the activities on the cathode, that's electrolysis of water. I don't know if it is in your syllabus. Maybe we still do it. In case you don't do it, when water is actually electrolyzed, hydrogen is always produced at the cathode. Cathode is the negative electrode, while anode is the positive electrode. So hydrogen is produced at the cathode. Let me write it down for you. So when water is electrolyzed, hydrogen is produced where? Hydrogen is produced at the cathode. Oxygen is produced at the anode. If time permits, we will see how this occurs. So water is actually a universal solvent. So let's check this topic. Water as universal solvent. Did you even check any question under air? So let's check questions under air. The jam questions I uploaded on the group. We'll check it. I'll look for questions on that. So water is a universal solvent because water dissolve arguably many substances. They can dissolve ionic compounds. They can dissolve ionic compounds. They can dissolve polar substances. And other reason why water is a good solvent is because it has high polarity. And I believe you understand what polarity means. You should by now. And they have strong hydrogen bond. Gift, what is the bond that exists between NaCl? Gift, are you there? Let me check.
Between what?
NaCl. Okay, we have Nicky Gold. Oh,
I think it is ionic bond
ionic bond. Why is that ionic bond?
because it's formed through the complete transfer of electron from metal to non-metal.
What's the metal?
Metal is sodium.
The non-metal is chlorine.
Hmm?
Nicky Gold. The non-metal is chlorine. I mean.
Yes.
Nicky Gold. Alpha. What's the bond that exists between CO2? Is Nicky Gold there? Are you there? Gold. Justice.
I think it's covalent bond
Covalent bond. Oh, that's nice.
because they are not metals, all of them.
Very good. So underwater also, we are clear to understand hard water, salt water, and I believe we've actually done justice to that. Salt waters, they form ladder easily with soap. I told you. And while hard water, they don't form ladder easily. But they form soap. Hard water forms scum. Salt water does not form scum. Is that taken? And we have two types of hardness. We have the temporary hardness and permanent hardness. The temporary hardness, let us do that one. The types of hardness. Temporary hardness, they are caused by the following. They are caused by calcium hydrogen carbonates. Can somebody give me the molecular formula for calcium hydrogen carbonates? and magnesium. Hydrogen carbonates. And they can be removed by burning. And you can add all this lime to it also. Can be removed by boiling. Hydrogen lime. For the permanent hardness, they are caused by calcium sulfate. And they can be removed by washing soda. But they can ask for the cause of temporary hardness. They can ask for the cause of permanent hardness. And they can ask on how it can be removed, how it can be managed. So for temporary hardness, it is caused by calcium hydrogen carbonates and magnesium hydrogen carbonates. And it can be removed by burning and hiding. Why permanent hardness is caused by calcium sulfate, magnesium chloride, and it can be removed by washing soda and ion exchange resin. We can write that down. Hello, hi guys. Done. It's okay. So Let's quickly move to. Did I even give you effect of hard water? These ones they are elementary actually. The waste scope, we said they don't form ladder. So they are not form you. You have to add a lot of soap before you can enjoy it. So they waste soap and they can create this black kettle effect. So they can scrape kettles and boilers. Can make a kettle black. Yes, another thing they can do is that they can block pipes. All right, that's them. So can create a funny kettle. They can block pipes. So let us talk about water. In case they ask you these aspects, just pay attention. Can ask you the function of different stages of water treatment. Stages of what? We have what is called screening. SCREENIN. It helps to remove large particles. Remove large particles. The next stage is sedimentation. Sedimentation simply means allowing heavy particles to settle down. Right? So heavy particles settle. The next process is coagulation. Coagulation simply means you want to clump the particles like tickling. So we add alum. Alum added to clump particles. Filtration. You know what filtration is? So we remove residues or to remove tiny solids. Chlorination. When you add chlorine to water, it helps to kill germs. Also, you can also boil. Boil can also kill germ chemical by adding it. Chlorine also helps to kill germs. And lastly, you can store and distribute. So they can ask you what is the function of chlorine. When we add chlorine, what effect does it make? Chlorine does not help us to remove large particles. Neither does it help to form clumps. What it helps is to kill germs. That is this infection. Is that taken to remove germs? So pay attention to all these water treatment stages and the individual functions of all these stages. Let's go to water crystallization. The Wikipedia talks about the deficient microscopy of herbicides. Then we'll check question and answers. Are you done writing this? Water of realization. The water of crystallization is talking about how some salt contains some percentage, or let's say it contains some numbers of water molecules in their crystals. Like when you check the volume or the mass of that salt, the mass that the salt will give you after weighing is not actually the mass of the salt again. There are some other components, especially water even, that is in the salt, that create an increase in the weight level or weight value of that salt molecule. So water crystallization talks about salt that contains fixed number of water molecules in their crystals. Salts containing fixed numbers water molecules. In their crystals. For example, copper sulfate, let's say 5 water crystallization. Sodium carbonate, 10 water crystallization. So we have the special phenomenon, which is where JAM will be testing you for water crystallization. For example, we have a case of efflorescence. I will look at efflorescence. We have another case of the liquescence. And we have hygroscopy. So let's take it one after the other, then we'll call it, check some questions and answer. So let's start with efflorescence. Please, I want you to pay attention to this aspect, please and please. So efflorescence is a special phenomenon of water crystallization. They have water crystallization before, but they will lose it and they will become bad. They will become powder. They get it. So there are substances. There are substances. There are substances that can lose, or they say that loses water of crystallization. And becomes powdery. We get it. For example, let's talk about this guy here. This Na2CO3. Na2CO3 0.10 molecules of water. They can undergo efflorescence to give Na2CO3. So Na2CO3 is an example of efflorescence because they've lost their water of crystallization and it becomes powdery. Please, is that taken? Okay. Let's go to so let's go to the liquid sense. What else? So the liquid sense, there are substances that they can absorb moisture. The effervescent, they can lose their own water of crystallization. The sediment sense, they are substances that can absorb moisture and dissolve in it. And dissolve in it. So they will absorb the moisture and they will dissolve in the moisture, like sodium hydroxide, like calcium chloride, and all. The last one is the hygroscopy. Hygroscopy is very similar to the liquid sense. They will absorb moisture, but they will not dissolve in it. So they absorb moisture, but they don't dissolve in it. I hope you understand the three difference between uh, efflorescent, effervescent, efflorescent, the liquescent, and hygroscopy now. All right, guys. So example of this includes quicklime, CaO, H2SO4. This one I said sodium hydroxide, calcium chloride. So we continue with water in the next class. Let's do a few questions. So I saw a summary table here. Let's do the summary table. So it talks about this phenomenon, that is the efflorescence, the decreasing and hygroscopy. Said absorbs water, dissolve. They dissolve. So for example, efflorescence reduces water, right? The decreasance the decreasance against water. Why hygroscopy? We also against water. But this one is not dissolved. Only this one dissolved. This one did not dissolve. In case they ask you, please do you understand the table? I'm gonna give to student. Let's check some. Let's check some past questions. Oh my God. Let's check the questions on that here. Before we move to water. So let's make like go back to comment. When you order. So gift, justice, and hazing. We're doing this together. So gift will come first. So gifts, you are the first person.
The answer is C. Can be separated by physical means.
Only I can see where people are.
Huh?
Yeah. Yeah, all right. So justice, over to you. Justice, are you there?
I'm here. So I did not come when the class started.
You're not the one in class at all.
Yes, but I think it's B.
You can see the highest proportion. No, B has a very low proportion.
B.
B, yes,
Wait.
B is very low. That's what I'm saying.
Okay.
Easy, are you there? Can you help me?
Can see.
Is it there? You don't know it.
So I'll take C.
No, the answer is C. Nothing has over 70%. They have scientific abundance in there. Answer is C. So it's over to you.
He's not in class, sir.
What do you say?
He's not in class.
Who is the third person in class? Oh, sorry, Paul. I want to. Yeah, I want to say Paul the other time when I said this. So, Paul, what's the answer?
I think it's B.
This one everybody is thinking.
I'm not sure. B.
Yeah, nitrogen. This one is very simple. Um, you'll be answering two questions gives because this question is a bonus question for you. What's the answer?
C. C. Fractional distillation of liquid air.
Okay. But this.
Oxygen.
Is oxygen. Maybe we should move to water. No? This question also is on that's just so justice happen. Just say that. There we go.
Okay, I'm here now. So I'm not seeing the
What's the answer?
question. I'm not seeing the question. Okay,
I'm not seeing the board or the question.
okay. I've seen it now. No, yes. Sir, A.
The noble gas are chemically inert because they have, you know, the noble gases. The group zero. Then why are they chemically inert? That is unreactive. The answer is C. They have a complete outer electron shells. They have a complete outer electron shells. Over to you. Oh, which gas is used in filling electric bulbs? I think I gave you.
Class C.
C. Argon. Yeah. What about lithium? Remember the function of the use of lithium.
Is also used to produce lights, but I don't think it's used to fill bulbs.
It's not used to fill bulbs. I give you the particular uses of lithium. Let me write it down.
No, I let me check.
What is the answer to this?
Uh,
Do you write it down? The use of neon, or you didn't write it?
Is used for all these advertising lights in signboard.
Okay. That's- Answer this question.
Is it me?
Yeah, now we are the first person. Okay.
Okay. It depends on the atmospheric condition because it's variable. Can be variable.
Very good. This one is simple. So justice will be doing two. It's a simple question. What weapon is this of oxygen? Justice, are you there?
Respiration. C.
Okay. So do this next question.
Justice.
Justice, you are still doing this next question.
Okay.
Are you there, Justice?
I'm here.
Are you still reading the question?
Um, let me take A.
Yeah.
Nitrogen, oxygen, argon.
C. Argon, nitrogen. What is it?
I said A. Nitrogen, oxygen, and argon.
Okay. They said arrange nitrogen, argon, and oxygen in order of increasing boiling points. So you start from the smallest, and nitrogen is less than oxygen. Oxygen is less than argon. Yeah, that is right. That is right. Give what happened.
It's not correct. The answer is D. Nitrogen is less than argon, and argon is less than oxygen. Oxygen has the highest boiling point.
Oxygen has. Oh, he said nitrogen, oxygen, argon.
I thought argon has more boiling point than oxygen.
Argon has boiling point of 186.
And oxygen 183.
I think I do. Yes. Do you
So-
understand that, Justice?
I'm the one talking, sir.
Yeah?
I'm the one that is talking. I'm asking now.
Okay.
Argon
So-
has higher boiling point than oxygen.
You guys are confusing me. Wait. Pardon me. I'm coming. Let me.
Wait.
The boiling point of nitrogen is minus 186, right?
Yes.
The boiling point of argon is minus 186.
A is correct. I don't know this.
And the boiling point of oxygen is minus 183. What did I give you? So if you want to arrange it now, nitrogen has the lowest, which is minus 186, followed by argon, which is 186, minus 186, and oxygen.
So, sir, which one is the correct answer?
Nitrogen has a lesser boiling point of argon. Argon has a lesser boiling point of oxygen. The correct answer is D.
Okay.
You get it. CO2 has minus 79. I think CO2 is there. CO2 has the highest boiling point. So,
I've not gotten it too. I've not gotten it.
you have not gotten it.
Mm.
The thing is somehow confusing. But
You see why I was asking if we should convert it to Kelvin that time, because if you had given us this thing in Kelvin, like
if you convert it to Kelvin, convert
It is-
nitrogen, argon, and oxygen to Kelvin. And tell me the value. The answer is D. It's nitrogen, argon, oxygen. Nitrogen will boil faster than argon. Argon will boil faster than oxygen. Oxygen will boil faster than CO2. That's the normal way. Please, Justice, you get that. Do everybody get that? So I think we are done with let's move to Gibbs. I'm waiting for you.
Me, how?
So to say want to convert it to Kelvin.
Yes, okay. I've converted it. Nitrogen is 77 degree Kelvin, argon 87, and oxygen 90.
You can see. This one has the highest. This one follow. This one the lowest. So it is 77 less than 87 less than 90. So it is still D. Do you get it? Let's go back to air. So we start with with Bob. So Paul, over to you.
So the answer is D.
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 Do you
D.
say D or B? Okay, D.
D.
Yeah. So it contains hydrogen and oxygen, which are chemically combined. So gifts, over to you.
See, size of that of oxygen.
We are laughing. What type of question is this?
Eh?
You are laughing. With what type of question is this?
No, I'm not even sure of my answer.
When water is electrolyzed, the volume of hydrogen is not H2O. 2 hydrogen, 1 oxygen. And it's toilet of oxygen, right? That's 2H1 now. I thought so. Justice Alpha. At least you met us in this class now.
I met you in the class, but not at this point.
Not at this point.
I came late. I came like this thing 10:40.
Eze, were you there?
Sir, I'm not there.
Okay. So Paul, over to you.
Yeah.
So C.
C. Calcium hydrogen oxocarbonates. Yeah. Just the logic, like I told you, is temporary hardness is due to bicarbonate of both calcium and magnesium. Either you see calcium hydrogen or you see magnesium bicarbonate. Anyway, anytime you see carbonate of either calcium or magnesium, it is caused by temporary due to that to cause temporary hardness. So give it over to you, since these people did not meet us.
See, addition of washing soda.
Oh, they are not serious. Why would they be putting for
Eh?
So why would they be putting boiling filtration on the? The question is a stupid question. That's what I'm saying. So what happened?
That to coagulate suspended particles.
Very good. So I think we are cleared with this. Can go and look at the other jam questions that the series that I sent to you guys. Keep sharper. Just to suffer. The next question. Give what's question 7.
Okay.
Which of the following substance exhibit the liquescence? Do you still remember what the liquescence are?
Yes. They absorb water and dissolve in it.
So you now say A. A has water already now. Should not even choose A or C. Answer is B.
D? Is it D or
B.
D?
B.
Okay.
This one will read it after the class. Justice, the number. Oh, the next question. Justice, are you there?
Good. A substance that absorbs moisture from the air without dissolving. Sir?
The substance that absorb moisture from the air without dissolving
C.
hygroscopic air. They will absorb moisture, but they will not dissolve it. So the last question for today. This is serious. Last question I'm saying is which of the following is an effect of hard water? A. Formation of ladder easily. B. Increase in soap efficiency. C. Formation of scum with soap. D. Low boiling points.
Formation of scum with soap.
Very good. So, what of selection refers to dash? That would be the last question. Anybody that knows the answer? What of salivation refers to? A. Water added in reactions. B. Water absorbed from the atmosphere. C. Water chemically combined in crystals. D. Free water in solution. Water of salivation refers to A. Water added during reactions. B. Water absorbed from the atmosphere. C. Water chemically combined in crystals. D. Free water in solutions.
C.
I would
C.
Eh?
C.
Water chemically combined in crystals. Yeah, you're right. Clap for yourself, guys. So this will be the end of today's class in chemistry. So we'll be meeting again on Monday on biology. I should teach more. Email. I should continue teaching. This is 12 now. Gift, you don't want me to go again, have you? I beg, let me go. So we meet again on Monday. for biology. So far we've moved a lot in biology, in chemistry. Like we covered a lot. Though we still have some topics that we yet to cover. But with the look of things now, we covered 45% in chemistry now. 45%.
45.
Yes, 45.
Is the 45 over 50 over 100?
I said 45%.
I'm saying the 45%, is it over 50 or over 100?
I said percent. What does percent mean?
Over 100, man.
So we've done 45 out of 100 already. So, chemistry syllabus is very wide and biology. Biology has about 22 chapters. So, but we are improving. We are going little by little. So, this is what I want to do. I will try and get you videos on the topics we won't be able to cover. That's why I'm trying to rush you guys. At least today in chemistry, we're able to finish air and we started water. And now we are even done with water. I will teach you electrolysis of water in the next class. Then we move to solubility. So by next class on chemistry, we should be done with solubility and the last part in water also. So from there, we move to another chapter like that. So if we can finish these chapters next week, we'll be at 55%. So upper week we will reach 65%. So by the last week in JAMB, we will be at 75 or 80%. So you guys you will do the rest yourself. Exactly. What gifts? So guys, let me end the recording. Give what is the issue now? And you don't go.